Hello buddies, my name is Substitution and I'm also known as Coach Sbu. Welcome into the Mathsbuddies channel. In this channel, I share with you lessons or methods you can use to solve any maths topic that you might or might not be struggling with as a grade 11 or a grade 12 learner. So if you are new to the channel, I would like to welcome you and I'd like to please subscribe so that you won't miss when another video gets uploaded. So without further ado, I'm going to jump straight into this week's session. This week we'll be talking about equations and inequalities. I'll be sharing methods on how you can complete the square, quadratic equation, equation with fractions, square root equation, and lastly, solving equation by substitution. Now starting off with the first one, which is completing the square. So now the aim of completing the square is this. So we want to take a quadratic expression and then we turn it into a complete square. So I call this form a complete square, right? But as you learn, when you get to functions, you get to know that this is a turning point form, right? And then this is a standard form. Alright, so here we want to I'll be showing you two methods on how you can complete the square on this expression and then also on this expression. Then now here we have following questions, and then the first one, it wants us to find whether these expressions have a minimum or a maximum. Then the second one, they want us to actually determine what that minimum or maximum is. And then lastly, they want us to find the x value at which we can obtain that minimum or maximum value. Now let's look into the method 1 of completing the square. Now the first method is by when you're basically looking at this x squared and then making sure that it has the coefficient of 1 first. Now here we see that we have 2x squared, so which means what we're going to do is we're going to take out that 2 out so that we can be left with x squared plus 5 over 2x minus 1 over 2. Now the aim here is so that this expression here, it has 1x squared, right? Or it has a coefficient of 1. Then from there what we do is we're going to keep that 2 from the side, and then inside here we're going to have x squared plus 5 over 2x, and then from right here we're going to say plus 5 over 2 times 1 over 2 squared minus 5 over 2 times 1 over 2 squared, right? Now what we just did here is we took this coefficient of the middle term and then we multiplied it by half, and then we squared that, and then we subtracted the same thing, right? Because if we subtract the same thing, this is going to be 0, and it means it doesn't change the expression, right? It just changes how it's basically written. And then after that we're gonna write minus 1 over 2. So this then means now when we complete the square, we're gonna have our square brackets, we're gonna have our round brackets, we're gonna square that, and then here we have x squared, so which means here we're gonna write x, and then this, when you simplify it, it gives you 5 over 4, but as you can see it is squared, so you're just gonna write 5 over 4. And then here the sign here, we're gonna take the sign of the middle term, so it means we're gonna put in plus there, and then what you see here is that we're gonna be left with this part. So that part, we're going to press that one into a calculator. Now pressing this on our calculator, remember I said it's going to be 5 over 4, that first part, squared minus 1 over 2. So when you press this on our calculator, we get minus 33 over 16, right? So this then means now we're going to multiply this here. So when we do that, we're going to have 2 into 5 over 4 squared. The 2 when we multiply there is going to be 33 over 8. So this means now we have completed the square. Now to answer the question, let's see whether this expression has a minimum or maximum value. Now for it to have a minimum, it means that a needs to be positive, and for it to have a maximum, then it means a needs to be negative. Now here, as we can see, the value of a is 2 and it is positive. Hence now this will have a minimum. Now number 2 says determine that minimum value. Now the minimum value is going to be actually this value here, right? From the turning point form or from the completed squared form, right? So this means now our actual minimum value is going to be minus 33 over 8. Now number 3 states that we need to give the value of x for which we can obtain that minimum. Now to do that, what we do is we take this value here on this complete square, right, and then we equate it to 0. So x plus 5 over 4 equals to 0, and then x is equals to minus 5 over 4, and that is basically how we solve all of them. Right, now let's look into the second method. Right, now the second method of completing the square, what you need to do is you need to know what is the value for a, which is minus 1 over 3, your value for b, which is 1, and then your value for c, which is minus 2. Now the way that this works is we already know what is happening with a, right? Is that here we have our a, so it means already here we're expecting a maximum. Now the way that this one then works is we first find the x value at which we can obtain that maximum, and then the next step is to actually find the actual maximum, right? So what's the first thing? First thing is finding the x value. Now how do you find the x value? So what we do, we're gonna say x is equals to minus b over 2a, right? Now minus, what is b? It is 1 over 2 into minus 1 over 3, right? And then if my math is right, when you press this on my calculator, you're gonna get 3 over 2, right? So this means x is equals to 3 over 2. Now do you remember earlier on here we had this answer as the x value at which we obtained our minimum? So this means when we reverse this, we got this, and then this was part of that, right? So this then means now, because if we want to write this expression in a completed squared form, what you're going to do is after having this, we're just going to reverse it into this equals to 0. But we already know that this is the actual x value at which we can obtain the what? The maximum. Alright, now the second part that you need to do is to find the maximum value then. Now how do we actually find the maximum value? Now to find the maximum value, we're just going to take this x value, then we're going to substitute it there on the expression. So in the expression we know that we have this plus x minus 2, so when we substitute it, it's going to be 3 over 2 squared plus 3 over 2 minus 2. So when we press this on our calculator, we're gonna have minus 1 over 3 into 3 over 2 squared plus 3 over 2 minus 2, which gives us minus 5 over 4. So this means this is going to be minus 5 over 4. So if I write this in a completed square, so this means I know my a is minus 1 over 3 into, and now inside the bracket I know I'm supposed to have x minus 3 over 2 squared, and then my maximum is going to be minus 5 over 4, and that is basically another way that we can complete the square. Now as you can see, this way we already answered all these questions there. We already know what is the maximum, and then we already know what is the minimum here. This is the minimum. We just highlight that. That's the minimum. Sorry, that's the maximum in this case. So we know what is the maximum, and then we also know the x value at which we can obtain that maximum. So let's go ahead and look into the next question. Now in the next question, which is the quadratic equation, we will be sharing the method of actually solving the quadratic equation. Now the idea of the quadratic equation is that whenever you factorize, you first need to make sure that you have what? You have a standard form. Alright, now here I'm going to be sharing two methods, but now with the first method I'm going to start with this one, right? So here what we're going to do is, first you can see that this is not a standard form. Why? Because this value here, it is not equals to 0, right? So this then means now the first thing you need to do is we need to write this in a standard form. So I'm going to multiply everything out. So I'll have x squared, so I'll be quick with this one, so it's going to be x squared plus 2x minus 8, and then I'm going to take the 7 across, so it's going to be minus 7 equals to 0. So now having the standard form is going to be x squared plus 2x minus 15 equals to 0. So now here the first method we all know is the one with the factors, right? So the factors is going to be x and x. Then now the factors of 15 that can give me 2 is 3 and 5. Now a bigger factor is 5, which means it's going to take the sign of the middle term. Then now positive times negative gives me negative, so which means x is 3 or x is minus 5. So we all know that, right? Now let's talk about the second one. Now the second method goes like this. So as you can see already, first things first, you need to make sure that your equation is in the standard form. As you can see here, this is in the standard form. And then now from here, you're gonna find what is your A and what is your B and what is your C, right? And then from there we're gonna apply a quadratic formula. But now here, this part you do not write it on your answer book, right? If you're writing a test, you do not write this part, what you're going to write here, because remember, when they give you this question, they already assume, especially if they didn't say leave your answer to 2 decimal, they know that you basically know how to factorize. So now if you don't know, or if you're still struggling with factorization, that's still okay, because this one is like a cheat. You can use this one to find the factors. So hence I'm saying you do not write this. So what is it that you don't write? So this thing you write it on your side or aside. You write it aside, so you write the quadratic formula like that, and then what you do in the quadratic formula is substitute the values, right? So here you're just solving for x, but using a calculator, which is then like a cheat, right? But it's not a cheat, it's just cooperating or using your resources wisely. Using your resources wisely, I like that one. All right, okay, so now let's go to the calculator and press this one. Now pressing this on our calculator, then I have minus 4, so I'm going to start with plus, and I'll say minus 4 squared minus 4 into minus 3 into 2 4. Now let me see what I get. So you can see here I get 3 over 2. Now let me look at the second one. So the first one I got 3 over 2, then the second one I got minus 1 over 2. So 3 over 2 minus 1 over 2, right? Now what do you do after this? So after this, you're just going to reverse all this and then you make it 0. So it means x minus 3 over 2 is equals to 0, or x plus 1 over 2 equals to 0. Then from here, remember, you are not using your calculator, you are cheating this. So when you factorize, most of the time they know that you cannot find factors that contain fractions. They only know that the only thing that you can do is only find the ones with actual numbers, right? So hence now what we're going to do here is we're going to multiply by whatever that is in the denominator everywhere. As you can see here, we can see in this first part the denominator is what? Is 2. So let me just see, since both sides it's 2, let me just do this and then I'll say multiply everything by 2. So when you multiply here by 2, you get 2x. When you multiply here by 2, you get minus 3 equals to 0, or do the same thing here, you get 2x plus 1 equals to 0. So this basically means now these are your factors. So now what is it that you're going to write? Now from your question, this is what you're going to write. You're going to take those factors. Remember, you were still there, right, at the first part. So the next step that you do from there, since it's already standard form, is this. Now you see it looks like you already knew the factors for that value. Well, you did because you had assistance, right? Alright, so this then means now 2x is equals to 3, 2x is equals to minus 1, divided by 2, 2, 2, then x is 3 over 2, x is equals to minus a half. So that's basically the second method for this one. So make sure that you apply with this one whenever you see a quadratic. Doesn't have to be, basically it doesn't have to be in a quadratic equation. It can also be in a quadratic expression. You can do the same thing, right? Look at it as if it has 0, but don't actually write the 0, and then find what are the answers, then reverse it into factors like this, right? Okay, so let's go ahead and move into the next part. And the next part, it is equations with fractions. Now in equations with fractions, we have two ways here, right? I have two expressions here, or equations. What I'm going to do is I'm going to basically explain how it works. Now the idea here is to basically factorize, right? And then once you factorize, you find your LCM, and then within the LCM you need to make sure that the answer that you get cannot be one of the LCMs, right? The solutions that you get in the LCM, because here the aim is to get rid of the denominator, but now the denominator, you can see it is an expression already, right? Or it has an expression. Here it is a trinomial, this is a binomial, and so on, right? So we're going to start off with the first one, right? Now with the first one, we're going to factorize. We're going to see if we can factorize the one at the top. Now looking in at the top in this first fraction, I can see that I cannot find factors. So which means if I cannot find factors, this part is already a factor, all of it, right? I consider it as a factor. Now let me look at the one at the bottom. So I'm going to say over. Now this one, yes, I can factorize this one, right? Now this is x, and then now the factors is 1 and 2, then I have minus and plus, right? Equals to, now x plus 2, is it a factor? No, but now I can make it 1 by putting it into a bracket like that. Now this also applies with x plus 1, and then minus 1, I'm going to leave it like that. Then now after doing this, I need to find my LCM. So what is my LCM? So this is going to be a product that I'm going to be multiplying it with, everywhere in this equation, and then it's going to help me eliminate basically all the denominators. So this means now in order for me to get that LCM, it needs to be basically all the vectors that are in the denominator, right? Now here x plus 1 and x plus 1 is already there, so I'm going to use x plus 1 is one of the factors, and then x minus 2 is also going to be one of the factors. Now remember, these are my LCM, but now, so I'll say such that, since I don't have the space to put the symbol there, such that now x cannot be minus 1, right? And x cannot be 2. Remember, these are the values from the denominator, so the minute I get a value which is minus 1, if I substitute it here, this is going to be an error, right? So which means my LCM has a restriction that whatever answer that I get at the end, it shouldn't be minus 1 or it shouldn't be 2. So let's go ahead and multiply with this LCM now. So when I multiply with the LCM here in the first term, I can see that it cancels everything there, right? So this means here at the top, I'm left with x squared minus 3x minus 7 equal. Now in this part, I have this x plus 2, right? So let me write the x plus 2. So now if I take the LCM and I multiply with this denominator, I can see it can only cancel out the x plus 1, leaving x minus 2, right? So this means, let me just write this color as purple just to show that this is the one that came from the LCM. And then here I have minus 1, and I do the same thing with minus 1. I didn't have any denominator, so this means everything that I got from the LCM, I'm going to write it as it is like that. Alright, I'm trying to isolate this. Okay, let me do that. There we go. Alright, so now let's simplify this. So standard form, let me just do that. So writing this in the standard form, I can see that this is a difference of 2 squared, so this means I get x squared minus 4. Then this part, it was the same as this one, as you can see, but now there's this minus, so I'm going to say minus 1 into, so instead of multiplying everything out, I already know that this is the answer for that, right? So I'll say x squared minus x minus 2, and then here I have x squared minus 3x minus 7 equals to x squared minus 4. Now I'm multiplying the minus 1 inside, I get minus x squared plus x plus 2. Alright, now let's go ahead and write this standard form. So writing the standard form, I'll start with the x squared. So it's going to be x squared, take the x squared over, this is going to be, oh actually this x squared cancels out with this minus x squared, so I only have x squared already. So this part I can just move on into minus 3x, and then with x moving across is going to be minus x. Then here I have minus 7. Taking this 4, this minus 4 plus 2 gives me minus 2, right? And if I take the minus 2 across, it's going to be plus 2 equals to 0. So this means now x squared minus 4x minus 5 equals to 0. Then here, remember, assuming that now we all know how to factorize. So if you don't know, use the quadratic formula, plus, and so x is equals to minus 1 or x is equals to 5. Now with this answer, you're going to ask yourself, in one of these answers I just got here, is there a restriction in one of them? And then how do we see that there was a restriction? We go back into the LCM. So remember, the LCM, it said we cannot have an x which is equals to minus 1 and an x which is 2, and then here we can see we have an x which is minus 1. So this means now this one is not allowed, but only the last part that is allowed. So x is going to be equals to 5. Now let's go ahead and look into the second expression. Now in this expression, we're given doing the same thing, but now here the idea here is that when we were basically factorizing here in this previous one, you notice that the value for x in the factors, it was positive, right? So this means now here here we need to basically do the same thing. When we're factorizing, we need to make sure that we keep our x as positive. The reason why I'm raising this is because I can see here I have an x which is a negative here, which means we need to change that one and write it into a positive, but I'm going to show you right now. So with this one, when I factorize the first part at the top, I see I have minus 3 as a common factor, so it means I'm going to be left with x minus 3 like that. Over the bottom I have x 1 and 2 plus minus, there we go, equal 4 over. Now with this part, let's see what do we have here. We have x. Now factors of a that can give me 6, I think it's 2 and 4, yep, plus, and then lastly, now with this last part I have plus 4 over. Now remember, this x I need it to be positive, right? So what I'm going to do is I'm going to take the x and bring it in front first, which is going to be minus x plus 1, but then now when I take out the negative factor, it's going to be x minus 1. Now if you try and multiply this back, this is going to be minus x, this is going to be plus 1, which is going to be exactly that, right? Then now also don't forget that positive divided by negative, this then means now this automatically becomes what? Becomes negative. So now let's go ahead and look into the LCM. Now the LCM, remember, is the factors on the denominator, because the aim is to eliminate all the denominator. So this means it's going to be x minus 1, because I can see there's x minus 1 here and there, and I can also see x plus 2, which is also in 2 of those, and then I can see x plus 4, which is also in this expression. Now I'm going to say such that x can be 1 and x can be minus 2 and x cannot be minus 4. Alright, let's go ahead and multiply. So when we multiply here in the first part, I can see that the x minus 1 and the x plus 2, they cancel, but I'm left with x plus 4. So this means, I remember I had x minus 3 into x minus 3, right? And now I'm left with what? As I'm multiplying there, I'm left with x plus 4, and then the x minus 1 and x plus 2, they cancel the denominator, right? So this means now I have equal 4. Now this also happens again. The x plus 2 got cancelled with this one, the x plus 4 got cancelled with this one. Then once that happens, we're going to be left with x minus 1 from the LCM, right? Now minus 4 again. Now we're going to do the same thing. The x minus 1 cancels out, and then we're left with x plus 2. We're left with x plus 2 into x plus 4. Alright, now let's simplify this. Now standard form, when you're simplifying this, I'm going to move faster. So this is going to be x squared, this and that. It's going to be plus x minus 12 equals to 4x minus 4 into, so x squared and plus 6x plus 8, right? Alright, now this is going to be minus 3x squared minus 3x plus 36 equals to 4x minus 4 minus 4x squared minus 24x minus 32. Now standard form, let's see. Standard form, so I'm going to take this minus 3x squared and this minus 4x squared, bring them together. So when I move the minus 4x squared, it gives me plus 4x squared, and then here I have 4x and minus 24x, which then give me minus 20x. So in this side I already had minus 3x, so when I'm moving that minus 20x, it becomes plus 20x, right? And then in this side I had 36, and then this part I have minus 4 here, I have this minus 4, and then this minus 32, which gives me minus 36. When I move it across, it gives me 36. Then I equate this to 0. So this means now here I have x squared plus 17x plus 72 equals to 0. Now here, because I don't want to waste time finding factors, I'm going to go straight into the quadratic formula, right? Because now it's going to take time for me to list all the factors of 72. So let me just apply the quadratic formula. And then now the nice thing about this one is you can basically apply the quadratic formula, because remember here we're not talking about quadratic equations, we're talking about equations with fraction, which means the tools that you've already learned in quadratic equation, you can apply them. Alright, now let's see what we have here. Minus 17 plus minus 17 squared minus 4 172 all divided by 2 into 1. Now x equal, or x equal. Now let's go ahead and go into our calculator. Now opening our calculator, we're just going to edit what we had earlier on. 1, our C now is 72, and then the value for A is 1, and then B 17, and then also 17. Now let's see. Now we get the first value, it is minus 9. Then now let's go ahead and look at the second one. It's minus 8. Minus 8. And then those are the answers. Now let's check. Is minus 9 part of the restriction? No. Is minus 8 part of the restriction? Also no. So this means that is our last answer, right? Alright, so let's go ahead and basically look into the square root equation. So now we left the square root equation and solving equations by substitution. Now in the square root equation, the idea here is to basically isolate the square root, right? So here, what do I mean by isolating by a square root, right? Now here I mean that you need to have a square root alone, whatever that it is here. Let me just say x plus a, and then on that side it doesn't matter what it is, bx plus c. It doesn't matter what that is, but we just need to isolate one square root so that we can square both sides. Now the aim here, by squaring this, it means this square root cancels with that, and then you're left with x plus a. Then here it doesn't matter what happens, you're just going to simplify, right? So this is going to be exactly the same thing that we're going to be doing here. And then the method is just one, it's just doing that. But here I had these two expressions so that I can show you when there's one square root and then there's two square root. So let's go ahead and start with the first one. So here, isolating this, I'm going to have x plus 8 equals to x minus 4. Now what do? We square. Square, square. Now this cancels with that. This side we left with x plus 8. Now here I don't want you to make any mistakes, because this, I know most of the mistakes, most of the people, they make mistakes on this part. So when you get something like this, always make sure that you expand it, because it becomes easier for you, right? So now once you expand this, then I understand that this is going to be x squared, right, minus 8x plus 16. So I understand you're going to get that as a result. So now let's take this x plus 8 and move it across, leaving 0 behind. X squared minus 8x, moving that x across is going to be minus x. Then here I had 16, moving the 8 across, it's going to be minus 8. So 0 is equals to x squared minus 9x plus 8. So let's go ahead and just inter-exchange all these things just to make it look proper. Alright, so now factorizing here, let's see. Factorizing, I'm going to get x, 1 and 8, minus and minus, so x is 1 or x is 8, and that is basically our final answer. Now let's go ahead and look into the second one. Now in the second one, the idea is the same thing. We just need to isolate one. So now I want to start with this value, since this one is like a little bit bigger, or it's higher, I don't know what to say, because here this expression is more complicated. So yeah, so we're going to isolate that one, x plus 3, and then this means we're going to take this one like that. Now from here, square both sides, and then x plus 3 equals to, remember, expand this, expand it to avoid confusions. And then from here, what do? We multiply, right? So when you multiply from this part on the left side, it's going to be the 4 method, right? So which means you're going to get 9, you're supposed to get 9 minus 6 root x plus x. Now where did I get this x? I said this times this is that, right? Which is 9. And then 3 times minus square root x is minus 3 root x. And then also when you do the same thing with here, we also get another minus 3 root x. Now minus 3 root x minus 3 root x gives you minus 6 root x. And then minus times minus gives you plus, and then square root x times square root x gives you x, right? But now here, what do you notice what is happening here? The first square root has disappeared, right? But now we still have another square root here. So this means we need to isolate that one. So how do we do this? Taking the 6 over 6 root x equals to, and then in this side we still have 9 plus x. Now when I take this x across, it's going to be minus x. Take the 3 across, it's going to be minus 3. Now x minus x, they cancel each other. Now 9 minus 3 gives me 6. And then here I have 6 root x, and then divide by 6, divide by 6. And then this means now here square root x is equals to 1. And then square, and then this means x is equals to 1. Now let's just double check, see if everything that we did here was right. Alright, squared, that's that. And then we got x there, and then we move this across. There we go. So that is basically our answer. So that's how we get the square root equation. Now let's go ahead and do the last part, which is the solving equations by substitution. Now solving equations by substitution, how are they basically different from square root equations and equations with fraction? Alright, now here it is not easy for you to see it, but the only way you get to see whether now you're not supposed to actually find the LCM, especially in this expression, is when you start multiplying, right? Let's say we see for this part here, I can't find the factors. For example, when you don't find the factors of a trinomial, and then there's also another trinomial that you can't find the factors of it, right? And then now this means now if you multiply by this denominator here, this value, this x, when it multiplies with this x squared, when it multiplies with it x squared, which will be an x with a power that is more than 2. So that's when you know that you're supposed to substitute. Can I repeat that? Right, let me repeat that. Right, now solving equations by substitution, this is how you see that you're supposed to basically do that, right? Now first things first is you check whether you can factorize these two, right? Now you can see we cannot factorize both of them, right? So now this then means if we want to find the LCM of this is going to be basically all of this, the denominator part. Let me just write it here. The LCM is going to be exactly x squared minus 5x plus 3. So this means now this value is supposed to multiply it. Remember, it is a factor. You're supposed to multiply it here. So when you multiply this here, the first part is going to be x squared times x squared, which gives you x4. So the minute you get x to the power of 4, and then this 4 is a power that is more than 2, then it means already you're not supposed to do that, right? You're supposed to keep your values at x squared, because this is still quadratic equations, right? I hope this makes sense. So this then means now the solving equation by substitution, it helps us to basically avoid powers that are more than 2. So now how do we basically do this? So to do this, we're going to create a substitution, right? So you're going to be saying let k be equals to basically x squared minus 5x, because the problem here is just here, right? Within these two things, this 3 is okay, this is the only problem, right? Why? Because if I take the x also and multiply with the x squared, it gives me x cubed, so which means these are the only two problems. So this means if we have this problem solved by a substitution, then this means this x squared minus 5x is going to be changed into k, and then I'll have plus 2 equals to 2 over, then this part again is going to be k plus 3. Now do you see what happens now? Now you see we're having something that we have done already, which is the equations with fractions. Now how do we know that? How do we know that? This is basically simple. The reason why we're saying that is because now this can be a factor and this can be a factor, and when we take k, when we multiply with k, it's going to be k to the power 2, which means the power to be exactly 2. So this means now here the LCM here, because of now we can see that this is like now it has changed into an equation with fraction. Our LCM is going to be k plus 3, which is the denominator part. Then now we know that k can't be minus 3, so let's go ahead and multiply with k plus 3. So when we multiply with k plus 3, remember we had k plus 2 there, and now we had nothing in the denominator, so it means this is going to be k plus 3. And then now we're going to say equal. Now here we have 2. Now the k plus 3 is going to cancel out with the k plus 3, and then we're just going to be left with 2. Now simplifying this, remember this is in the standard form, so it means we need to multiply it out first. So it's going to be k squared plus 5k plus 6. When you simplify it, take the 2 across, it's going to be 0. Now k squared plus 5k plus 4 equals to 0. So when we factorize, we're going to get k 1 and 4 plus plus, so it means k, it is minus 1, or k, it is equals to what? It is equals to minus 4, right? Now remember, are we solving for k here? No, we're solving for x. So this means now once we have identified what is our value for k, we then substitute the x back. So x squared minus 5x is equals to minus 1, or x squared minus 5x is equals to minus 4, right? And then from what we see here, I'm going to have x squared minus 5x plus 1 plus to 0, or here I'm going to have x squared minus 5x plus 4 equals to 0. So now here, let's see, can we find factorization of this one? Let's see and check if we can find it, because here I can't find the factors, but let's test it on a quadratic formula. Looking at the quadratic formula, we can see that our a is 1, which is okay like that, and then our c, it is also 1, so let's put it 1 there. A is 1, that's cool. Now b is minus 5, remember we're testing it, because it is very important that you always test it when you can't find the factors. Minus 5, see, you're getting the value right? So when you apply the quadratic formula there, we do get the value. Let me just double check that we got everything right. Minus that a c over 2a. Alright, so that is our answer. So we're getting x as 4,79, right? So we have x is equals to 4,79, or now let's look at the second one. Second one minus, it is 0,21, Then now here, sorry, x equals to 0 comma 2 1. Now in this second part we can factorize this one, right? So when we factorize this one, we know this is 1 4 minus minus, so x is equals to 1, or x is equals to 4. So therefore this means our values is x is equals to 0 comma 2 1, x is equals to 4 comma 7 9, x is equals to 1, and x is equals to 4. Then that is our answer. Now let's go ahead and do the last part. Now with the last part, this is exactly the same thing, right? You're gonna basically be doing the same thing because you're trying to avoid having what? Trying to avoid having something that's going to be confusing, right? Now here I can see that we have a square root in the denominator there. So the easy way to do this is if you can basically make k to be like this, right? So substitution, what are you going to do? I'm going to say let k is equals to square root of x plus 5. Now before I continue, I can see with this one that I can just multiply right through with the square root of x plus 5. Now because of here we're working with the solving equation by substitution, and the purpose of this part is to show you how you can do substitution. Now it means it's easy for me to basically follow that, right? So let me just follow that one. So this means I have k plus 8 is equals to 20 over k, right? Now my LCM is just k, right? Then if it's just k, then it means it's k such that k can't be 0, because remember k can be written as k plus 0, or you can just write it as k minus 0. It doesn't matter, but it will obtain 0 on the other side, right? Alright, so let's multiply with the k everywhere. So when you multiply by k here, you're getting k squared. When you multiply by k in this part, you get 8k equals to 20. Now k squared plus 8k minus 20 is equals to 0. Then now here I can see that 10 times 2 is 20. So my factors will be k, 2, 10. This times that is 10. Then this times that is negative. So this means k is 2, or k is minus 10. Alright, now what is k? K is square root of x plus 5 equals to 2, or square root of x plus 5 is equals to minus 10, right? Now here what we're going to do in this part, we're going to square, and then x plus 5 is equals to 4, and then x is going to be 1. Now what about this side? Now this side we're also going to do the same thing, square, x plus 5 is equals to 100, and then x, this is minus 1, and then x is going to be minus 95. Now with this one, because of you had a square root, x plus 5 equals to a negative answer, it means now we need to basically test this. So whenever you're getting a square root, an equation that has a square root, x plus 5 equals to into something negative, then it means you need to test the answers once you're done, right? Or you just do it this way. Whenever you're working with the square root equation, test the answers at the end. So let's go ahead and test our answers here, right? So when we test this one, we're going to test the value for minus 1 first. So let's do that one. So when I'm testing this, I'll basically write exactly what's there. So minus 1 plus 5 plus 8. So I'm getting 10. So I'm supposed to get the same thing when I take 20 over square root minus 1 plus 5, getting 10, right? See, 10, 10. Now let's try another one, the second one, which is 95. 95, I'm getting an error. You see that, right? Getting an error. Let me see the second part. Of course I'm gonna get an error also, right? So this means here this one is not it, but this one is it. Then answer, it is x is equals to -1, and that is the end of our method sessions. So that's all I got for you today, guys. If you like the video, make sure you like it, share it with your friends so that they can basically see some of the methods that might be very useful to them. And also make sure that when you're learning these methods, rewatch this video, watch one of the topics, and then pause that video and then look into actually some of the exercises or more of the exercises, and see you can basically master the method before you can actually go into the next one. And that is all for today, and I'm going to see you on to the next one. Cheers.